All right, binomial probabilities, page 2. We're going to look at actually how to calculate them. All right, so we have a few different things to identify first. So first off, n represents the number of trials. Pi represents the probability of success, or sometimes it's also called p. So we get this formula. The probability of x equals n, choose x, pi to the x times 1 minus pi to the n minus x. So the expression n choose x, or written this way with the parentheses, is read as n choose x. This is called a combination. Okay. So let n equal 50 and pi equals 0.4. So that means the probability of success is 40%. That means the probability of failure is 60%. That's what this 1 minus pi is, the probability of failure. All right, and we have n equals 50, so we want to know the probability of getting exactly 10 successes. So that would be n choose x, so 50 c 10, pi to the 10th, so 0.4 to the 10th, and 0.6 to the 40th, because this is the probability of having 10 successes. But if there's 50 trials, if we had 10 successes, that means we had 40 failures. So 0.6 to the 40th. So we can plug that in, or on a TI-84 or 83, there is a binomial distribution, and this is called a binomial PDF, P for a single point. And you put n, comma, pi, comma, x, and you get approximately 0.001. And we'll have to find another one on the computer that you could use if you don't have a TI-83 or 84. All right, so this is the probability that x is less than 10. That means anything from 0 to 9. So you'd have to do this 10 times, one for each of these, probability of 0, probability of 1, probability of 2, or the calculators have one where it's called binomial CDF. This is cumulative. So the C stands for cumulative, and you plug it in the same way. So 50.4, but notice there's no equal sign on the 10, so I'm only going up to 9. And that gives me approximately 7.57 times 10 to the negative 4. And so this is what it looks like on the TI-83 and 84s. And again, we'll have to find something on the computer that you can do. If you just Google, binomial calculator, you'll find lots of choices that are free. Okay, so C is almost the same, but notice this says less than or equal to. So this is starting at 0, but it's going up to 10. So the only difference, I still did a CDF. There were still 50 trials. Success is still 40%, but the difference is instead of going up to 9, I'm going up to 10. So this is 0.002. So this is basically like saying I took 50 shots in basketball, and I'm not very good, so that's actually high for me. I have a 40% chance of making the shot. And what would be the probability that I would make 10 or fewer out of those 50 shots? Okay. All right, so now what's the probability that I would make more than 10? So that would be 11 shots, or 12 shots, or 13, or all the way up to miracle of miracles, I make all 50 shots. Well, the calculator doesn't do that. The online calculators might, but the TI-83 and 84s doesn't do greater than. It only does less than or equal to. But that's easy to do because we know all the probabilities together have to add up to 1. So all I'm going to do is 1 minus the ones that I don't want. And then that'll leave me with the ones that I do want. So 1 minus the same thing we did here, binomial CDF 50.410, because that takes away everything 10 and below, which leaves me with anything above 10, so 0.998. Right, and then this one, greater than or equal to 10. So this time I want the 10. I'm going the probability of 10, or 11, or 12, or all the way up to or 50. So this time I'm only going to subtract away up to 9. So 1 minus binomial CDF, 50.49. So I have a 99.9% chance of making at least 10 shots. All right, so example 2. Suppose you are taking a 10-question multiple choice test. Each question has 5 choices. You have no idea how to answer any of them, so you just guess. Let x equal the number of correct guesses. Okay, so n would equal 10 because it's a 10-question test. There's 5 choices for each one, and only one choice is correct, so the probability of success is 1/5. So A, find the probability you get 4 correct. So exactly 4. That's the PDF. P for a single point. Binomial PDF 10 1/5 4 is approximately 0.088. Okay. Probability that you get no more than 4 correct. That means x is less than or equal to 4. So that would be a CDF, a cumulative, 10 1/5 4, and there is a 96.7% chance that you would get no more than 4 correct. Okay, the probability you get 2 or more correct. So x is greater than or equal to 2, but remember the calculator doesn't do this, so we need to do 1 minus x is less than or equal to 1, take away the ones we don't want. So 1 minus binomial CDF 10 1/5 1, and we get 0.624, so a 62.4% chance that you get 2 or more correct. Okay. What's the probability that you actually pass the quiz? So to me, passing means you got a C or better, so we're saying what's the probability that x is greater than or equal to 7? That you got at least 7 answers correct. And again, calculator doesn't do greater than, so I have to do 1 minus up to 6. So the probability that x is less than or equal to 6, I'm taking away the ones I don't want. So 1 minus binomial CDF, 10 1/5 6, is 8.64 times 10 to the negative 4. So that would be 0.0008. So that's a less than 1% chance of actually passing the quiz if you were to guess on every single question. All right, so that's page 2 of the binomial distribution, my lovelies. Bye.